So one real-world application of geometric sequences, remember those are multiplying patterns, is called exponential growth. Exponential growth involves a quantity that's increasing by a percentage. So all of the patterns that we've been looking at so far, they have been increasing by multiplying by some integer, so 2, 3, 4. Or sometimes that they're decreasing, and so we're multiplying by like a half or a third. Um, but with an exponential growth problem, we're actually going to be increasing by a percentage, and we're going to change that percentage into whatever we're multiplying by. So let me show you. The other thing is recall that the general form of a geometric sequence is a of n equals a sub 1 times r raised to the n minus 1. Okay, and we learned that a sub 1 is our starting value. Okay, it's the first term, and r is our common ratio. It's what we're multiplying by. The formula for exponential growth is actually exactly the same, but we just use different letters. I don't really know why. So we're going to still call it, we're still going to call it a of n, only this time it's going to be our starting value, which for some reason is p, and then that's going to be multiplied by r, our rate, which is very similar to the ratio, raised to the t. Listen, guys, these are literally the exact same thing. There's no difference between them. It's just for some unknown reason, we bring in more letters because why not? Okay, the hardest part about these problems is that we have to convert a percentage into our rate, which is what we're plugging into the formula. So it's real simple, okay? If you have a 32% increase, okay, a 32% increase, what we're going to do is we're going to add that to 100. We can account for the fact that this is an increase by just adding it to 100. So we're really going to change this to 132%. We don't have to put the increasing arrow after this anymore because 132% means getting bigger by 32%. That's what it means. But we don't put percentages into our formula. We have to change our percentage into its decimal equivalent, which we do by dividing by 100. So here we added to 100%, and then we divide that number by 100, and we get 1.32, and this is R. That's R. That's what's going to go into the formula. So let's do an example problem here. Maddie's applying for a new job. She was told that her starting salary would be $46,250. She'd receive a raise of 1.9% each year. She plans to stay for the company for 5 years. What will her salary be in the 5th year? Okay, so let's start by our conversion. 1.9% increase means we're going to add that to 100 and get 101.9%. And then we divide that by 100 and we get 1.019. So there's R. Our starting salary is right here. So there's our starting value. And then 5 years is going to be T. So here we go. A of n, actually in this case it's A of t because our variable is t, is going to be P times R raised to the t, where P is our starting value. So A of 5, which is what we're looking for, is going to be 46,250, our starting value, times, we often just put this in parentheses, but it's not required, our rate raised to our time, which is 5. And then we would go to our calculator, 46,250 times 1.019 raised to the fifth. I wrote this exact thing in my calculator. And when I did that, you should do it along just to make sure that you're typing it in the calculator correctly. I got 50,813.92. So her salary in the fifth year would be $50,813.92. And that's how exponential growth problems work. Now, a couple of things to know. Doubling. Let's just make sure we know what these words means. This means multiplying by 2 or you could think of it as a 100% increase, which means when you convert that, it's actually going to become 200%. And when you divide by 100, it's actually going to become a rate of 2, which puts us right back where we were. Tripling means multiplying by 3, or you could think of it as a 200% increase, okay? Which, when you convert it, you're going to add to 100, which gives you 300%. Divide by 100 gives you back to 3. So you can see how these two things are connected here. Multiplying by 3 is the same thing as a 200% increase. Multiplying by 2 is the same as a 100% increase. So go try the practice and let's see how we do with this.